Dear students, so today we'll talk about big data storage technology. As we know that storage is a very huge issue with the big data, because we know that there are three most important things as a volume, velocity, and veracity. So as the one of the V, which is volume, the data storage plays a very important role, and we need to manage it. So how to manage it? So there is a technology which is called cluster technology, in which many computers, many GPUs are interconnected, and where the tasks are divided among the different GPUs or computers and then reintegrated to the user. So we will see that what are the different technology in the big data storage and how it is helping us to manage the big data. So now here you can see that is the one disk storage can be implemented with the distributed file system or a database. So as I told you that your file has been divided into many parts across the different processors, right? So you can see here like your database, which is like usually in the big data NoSQL is used, not the normal SQL. So as we know that with the MongoDB database can also be used. MongoDB is one of the expert option, which is which databases or the big data is using it, and they can easily handle the documents, the very different varieties of the documents. Like for example, if we have a tweets data online is streaming the tweets data, or if you have the data set, so you can store that data in a different document shapes using the NoSQL or the MongoDB or Hive or Hadoop or any structure you follow, or HBase. Now you can see that how the distributed file system is accessing the data in streaming mode with no random reads and writes. You can see here we have like unstructured data. You can see unstructured data which is in the shape of images or videos or XML file or JSON file. So we have the totally unstructured data and we have semi-structured data, and this is being loaded into the DFS file, the distributed file system. So HDFS means Hadoop distributed file system, or if you say DFS means it's a distributed file system, and then the data is being like streamed into the wire and in the form of the 0 1. So all this data is streamed into the wire in the form of the 0 1. Now you can see it's a cluster of a relational database, the normal relational database, which is used in the shared storage architecture, which is like a potential single point for failure, and it could affect the availability of the database as well. So here, like node A, there is a write operation. Node B, there is also a write operation, and node C, there is also write operation. So processors are three, but the storage is one here in this case. Now here you can see a relational database is manually sharded. Sharded means like it's divided, like with using application logic. So application logic is a program which has a capability to split the data which is already in the form of the tables. Okay, so you can see we have the four different rows, row 1, 2, 3, 4, and this has been sharded, or it has been divided into two parts. So record 1 for the Bob and Helen is in shard A, and the record for John and Jane, which is ID number 3 and 4, is in the shard B, right? So this is one of the application which can divide it, and that application name is application logic. So it helps us into dividing the data horizontally into different parts. There's another example where we can use the application logic to join the data retrieved from multiple shards, right? So on another hand, if you want to retrieve it back, so here you just send the data and here you retrieve the data back, and how you can combine, for example, if you want to combine the row 1, which is the Bob and its date of birth, and with the row 3, which is the John with the date of birth. If you want to combine, you can do that as well using the application logic module. Yeah, so this is a typical symbol for NoSQL database. So NoSQL means not only SQL, it means it's more than the normal SQL, where is only tables, but here we deal with the real documents, with the videos, with the audios, with the images, with like normal as the like normal like documents. So this is like a very specialized form of structured query language, and how we represent it with this yellow box. So this is a one of interesting example of NoSQL storage, and that how we store the NoSQL. And here we use a key value technique. So what is the key? Key is the number we generate for it for every records, and the value. So value could like you can see the value is not symmetrical. It is not like same that in normal databases in one column we store like for example names. So all would should be name. If you use the salary, so all should be salary. If you use as a grade, so all would be grades, right? So, but here in this one, you can see we just assign a key and which is 631 and we put all the data, whatever the data comes. And similarly, 635, it's an image data you can see over here. And in the key 198, it's a XML kind of file or JSON file. This is an example of how we store it. So this is a typical example of a JSON file, and you might have experienced this in Mongo DB. That in how in the Mongo DB this file looks like, and it can be utilized and it could be accessed like a normal database. This is another example of column family NoSQL storage. So this is like, see, there's a great variations. It is not like a normal SQL Oracle one, but here you can see with the student ID, you have like personal details for one students. And for the another students, it's not necessary that we include like, for example, first name, last name, date of birth, gender, ethnicity. So in the second row, in 742, ethnicity is missing, is missing. And so in the second one, address, so address one address is longer in 821 students number, but in 742 the address is shorter. And similarly in the module you can see the modules are different and but they are same here. So it depends that so there is a high variability, high changes in the no data and in a big data. Now here, this is another example of graph structure. In a graph, how can we store the data? So you see over here in the graph, this is one of the structure that related to the TV about the customers, and customer is like, changing values here. So this pretty looks, it looks like same like the normal SQL, but there could be more variation as well. Okay, this is another, yeah, the same example which I explained earlier. So the first row is containing the normal text from any text file, txt file. Second is 365 key, and it has a pure image. So you can see the image value is from 0101. And usually, if you read the images in MATLAB or in Python, so basically images values are every pixel is storing from 0 to 255. So 255 is the last digit, and 0 from the starting from the 0. The second one is the third one is 198, which is a pure XML file, and the HTML tags are used here for starting in a record and ending a record. So slash is used to end a record, and without slash is the starting of that record. Here you can see that it's a very typical JSON file, which is very commonly used in a MongoDB campus or Mongo shell as well. You can see. So here the structure is a little bit different with respect to the XML. So XML, they are purely using the HTML tags, while this one they are using the curly brackets and the big brackets. Right, here is like, the highlighted columns depict the flexible schema feature supported by the column family database, where each row can have different set of columns. So you can see over here, like, there is a high variation. You can see that the personal detail column is different from the above. So address is different, and in the case the last module history is the same. In the graph structure, storage devices, entities, and their relationships. So in the graph is a very interesting thing, and if graph were not there, so most of the computer programs would not be there. So graph gives us a very good direction to interpret the data and to parse the data, and especially for in searching it like, it ease the searching, and even it like, decrease the searching time if it is binary. So most probably like, mostly like, it cuts the time into the half. So that when it cuts the time into the half, that is like, most interesting thing. So usually the processing is like, if it is a O of n squared is a high processing time. If it is like, O of n is very low time. If it is n log n is a moderate time. So in algorithms we usually calculate the processing time for the searching. Now, there we have two concepts. In-memory storage devices, when you like keep the storage inside the RAM. So the symbol which is used to represent is is like this one, and that is called in-memory storage device. And in-memory storage device are 80 times faster at transferring the data on a disk storage device. So disk storage devices, it takes more time, while like in-memory storage devices, they are more faster, because here you can process and store together. So the transferring times becomes is saved. Another we have IMDG. So IMDG is also is a variation in that one, and which is here you can, it is like more facilities is here. So in-memory data grid, so IMDG is like a new concept, and has been adopted by Hadoop for big data processing. So it is a bit different than the previous one with respect to the processing. So you can see over here, the symbol is even different over here. So you can see the processing over here, and IMDG storage devices is used over here, and in that one, the data is stored. So whether it's image data or XML data or customer data, which is stored in the IMDG data grid, and it has been processed. If you can see that we process the different type big data, and from that one we just go for serialization, and from serialization it is processed into the IMDG data, and from IMDG data you can do get and put process. So you can see over here, when you push the data into the IMDG, that is called get. When you pop up to, that is called a put information over there. So this is a relatively very interesting concept. And here is more processing time, that how the processing done. So by this way you save time, instead of pushing the data to the hard drive and then to the RAM, and then from RAM to the hard drive, because of the high volume, that could be an issue for us. So an IMDG deployed in a cloud scales out automatically as demand for the data storage for the storage increases. So you can see over here, when a lot of data is coming on the cloud, yeah, and you can easily process it, because you have both the processing from the RAM and the drive as well, and the disk as well. And this is an example of using IMDGB with the read-through approach. So in the read-through approach, is is bit different, and it gives you that how can you can get the data and put the data with respect to the NoSQL. So NoSQL stands from not only SQL. And apart from that one, you can see that how the key value pair works. So key is a value through which you can track the value of the big data, and you can process it in a similar way. And some of the example of the right behind approach. So how we do the right behind approach while storing the data and retrieving the data. So we use get operation, or sometimes we do the update operations, and sometimes we ask it to queue it so that the previous operation should be done before then the new operations. And leveraging the refresh ahead approach. Yeah, so usually there are some mistakes happens when there is an update operation, there is a delay in the update operation, or new operation has not been updated. So there is we have ACID property in normal SQL. Similarly, we have different properties, the state properties in the big data. So that will also be discussed in the next chapter. So IMDb database concepts is also there, and it's a similar concept with respect to the IMDG. And these are certain examples. You can see that how we can update, and you can see the normal SQL query select static from sensor where temperature is greater than 75, and it has been processed same like. So thank you very much, and see you in the next chapter.